Hello, welcome to today's video about modern engineering and progress. This is the third video I'm recording, and the plan is the following. We're going to talk about progress a little bit, what that is. It is obvious to you, but we can discuss what that used to be and why wasn't it so clear before. Then we will talk about modern engineering, what modern engineering is, and the final thought is that I wanted you to understand what kind of figure a modern engineer is, how he is perceived in today's culture, and why is it so great and important that you are pursuing the career in engineering. So, without further ado, let's move on to the first idea, human progress. You all are familiar with what human progress is and why I like the humanity so much, and why I'm proud to be part of the humanity, is that we as humans tend to get better at what we are doing. No matter what we are doing, as the saying goes, if you spend a lot of time on something you do, you get better at this. And this picture here is a great example of glassmaking and having progress in glassmaking. As you can see, the first glass pieces were really horrible, and what amazing things we can do now with glass is kind of astonishing and groundbreaking, especially if we compare that with the first documented or known to history pieces of glass that we made. So in terms of progress, this wasn't an easy thing. This was a really slow-paced development, and we used this method that we call trial and error. So the craftsmen and artisans, they try different methods and techniques. They try this and that, and if they succeeded, they passed this knowledge on how to better use the techniques of glassmaking, for example. And it is also true to any other craft or any other pre-engineering, pre-modern technology that we had. Like, we spent a lot of time developing that, for example, glassmaking or architecture, or building houses, or wood cutting and pottery and stuff like that. So we developed these crafts by trial and error, and those who got a lot of experience in this field could pass their knowledge on to the next generations, and that's how the humanity got the progress. So if you look at this time graph closely, you will see that this graph has some highlights of the most important historic conventions in time. So we start with fire, and we end up with reusable launch systems done by Elon Musk and engineers from SpaceX. So this took us a long way, but if you look closer, you will see that this timeline is not equally distributed. So although you can see that these lines look the same in length, it took us about 1500 years to develop some writing system after we developed the wheel, after we invented the wheel. But it took us about, let's say, how many is that? 17 years to build the first airplane after we built the first car. So as you can see in here, in this left part of the graph, the time spans between the events take a longer time. And if you imagine yourself living in, for example, 2nd century AD, you can imagine how difficult it was to actually perceive any kind of progress or see the progress with your own eyes, because you would live the life the same way your parents did and your grandparents did and their grandparents did. So nothing changes drastically if you live in this part of the time scale. But if you, like me, started your life like in the late 1990s or 1980s, you could see that the development, the progress of mankind was really drastic. It is being drastic and at astonishing speed, because 10 years ago I couldn't imagine myself streaming this video live, or uploading this video uh, on the internet with the perfect resolution, almost HD, with a solid 30 FPS. But this happens now because we get better, and the speed with which we get better at solving problems and at, I don't know, developing new products and creating new technologies is fascinating. It's extremely fast, especially if we compare that to the old times, to the past or prehistoric era, when we had really small and slow-paced movement in terms of progress. So if you live here in the 20s or the 21st century, the idea of progress always stays with you. You are quite sure that there is progress, and the progress will keep on going because we have this much pace built up. But if you live in the past, it wasn't such an obvious idea for you, because nothing, in general, nothing changed throughout the whole course of your life. So let's thank our ancestors for that and keep on doing the progress, you know. So as for the old times, the progress that we had before that, it was through craft mainly, and craft, as I can see, is kind of a ancestor to modern engineering art, to modern engineering science. It's when you make progress through some trial and error. You try different stuff, and when you achieve the results, you achieve the results because you have enough experience, and that provides you with insight or some intuition on how to get your production more efficient or get your products better. So then you have to pass your experience on to the following generations, to the next generation, so that it will keep on building up the momentum. And because we kept on building up this momentum, this pace, we are now living in much better, uncomparably better conditions than our ancestors used to hundreds and thousands of years ago. So the thing that I wanted to highlight is that progress doesn't necessarily happen because of science. Of course, science is a way to build up progress, to develop further on, but science itself is just new ideas or thoughts or knowledge about the way the universe works. But the people who bring these ideas down to earth, bring these ideas to people in order to change their lives and to make some money in the process, are of course engineers and entrepreneurs. These people have enough, those people who have enough knowledge and understanding and resourcefulness, of course, to get hold of these scientific discoveries and ideas that, for example, Maxwell or Newton or Einstein came up with, and turned them into plausible, feasible things that people could use on a daily basis that could make people's lives better. So when this happens in the 19th, 20th century, we're not talking about craft anymore. We talk about engineering, science, and these three words, like method, technique, and technology, come into place. So method, technique is like a small idea that you use in order to make small improvement in your production process. A method is a more general word, and the most general word out of them is the word technology. That is a combination of all the methods and techniques that you use. So there can be production technology or logistics technology or any kind of engineering technology that you know. These all engineering ideas, these all technologies, they influence our lives the most and continue to influence them, will continue to influence them further on in time. So that the STEM sciences, our sciences like science, technology, engineering, mathematics sciences, are becoming more and more important. So engineers are those people who apply what they know and to real life situations, to the problems, in order to find some solution. And this cannot be less inspiring. See, so what is modern engineering? This is a vast field that covers almost every part, every sphere of human activity. Of course, if you Google engineering and look for the pictures, or you will see that the most common pictures are connected to what we call civil engineering. That is building huge structures, or building infrastructure for transport, logistics, and people to live happily their lives and conduct research, or I don't know, simply to relax on a artificial resort like this one. So then we have power engineering. This is also very important, because the problem with modern production and technology is that it needs more and more power. So power engineering and producing, storing, and transferring energy from one part of the planet to the other is one of the most important aspects of engineering. Then we got automobile engineering. This is basically the creating new ways of transport, new vehicles. And then in the 70s, 90s, we started developing new novel types of engineering, like automated systems and cybernetics, blossomed from the 50s and 60s. And then, of course, we have your field, software engineering. That is the technology of producing and honing that software that you are able or will be able to build in the nearest future. Of course, this is not everything that engineering is. There are lots of other fields, so you see there are lots of other ideas that I didn't put on the slide, but you get an idea of what engineering is and how important that is. So basically, what our book says about engineering is that engineering is a way to transport, transform, or control the raw materials and energy. And by raw materials and energy, I mean, of course, these resources that our planet provides, nature provides, the forces of nature themselves, and information. It's also part of the energy that we can transform and control. So basically what that requires from an engineer is being resourceful and knowledgeable. And I hope that you will become one day this kind of engineer, resourceful and knowledgeable person who is able to turn the things he has around him into the solutions for his or her problems, to make the lives of his friends, relatives, and other people better. And it's even better if you can earn money by doing so, because this is like the most noble thing to do, like earning money by making other people's lives better, fighting starvation or famine, or fighting droughts or floods. This is like the most noble thing to do. So in the 1970s, in the 1980s, we start to move from like this traditional view on engineering, like the way to master the nature and kind of make it work for ourselves, to a more human factored engineering. So we take human factors into account, and this is what we call ergonomics and design. So from the 1970s we start thinking, and even before, but 1970s was like the turning point. We start thinking about the person behind the machine, so the operator, and we start implementing in our design these principles of ergonomics, so that it will be easier, it will be more user-friendly to use the machine. So this is also one of the key important features of modern engineering. So you need to think about the operator, the person who is dealing with your machine, with your product, so that it will be easier to operate. Even like a jar of honey should be enough to open, but not as easy as for a kid to open it, especially if we're talking about drugs and medicine. Another example is the syringes that we have developed lately. So a usual syringe is intended to be used only once because it doesn't it stops being sterile after that. But this is a big problem with drug addicts and people who can't afford buying a new syringe and using new syringe every time they need I don't know, a shot of a drug or medicine. This is a big problem in developing countries in Africa and South America, things like that. So drug addicts there and in any other country, they transmit and transmit different diseases because they tend to use the same syringe over and over again with different people, and this is of course bad. So engineers nowadays have come up with a different design of a syringe so that it can only be used once, and then it physically breaks after the first injection. It physically breaks the needle so that nobody is able to use the syringe again, even if they want to. Even if they try, they will not be able to do that. And this is what I also like about engineering and design and the ergonomics, that you can build the care of others into your product. So sustainable development and sustainable production is a different thing. It's a different movement that also started in the 70s after we decided to think more about our planet, about the environment. So sustainable development, as the definition goes, is when you try to build your production routine, your technologies of production, so that there is almost no waste or no waste, so that it's a closed circle production. You recycle more, you use recycled materials in your production, so that the development of the production gets sustainable. So, and also a big plus to the engineering is that we now tend to develop new spheres of engineering where we can apply engineering, and that is of course medical engineering and biotechnology, bioengineering, that are starting to develop nowadays. That's basically everything I needed to tell you so far today. There is quite a long homework, so you could read this text in Shevtsova 7a about modern engineering. I will send it to you in a PDF file here, and please complete exercises 12, 13 and 18 after the text so that you will pick up some vocabulary. And also in 2 weeks time you need to write down your own personal take on engineering in the 21st century, what kind of thing that is, and why do you think you would like to be an engineer, a modern magician or wizard if you wish. So thank you for your attention. That was a pleasure again. So I will keep uploading these videos, and I will keep I will keep you posted upon the videos. So if you skip the online transmissions, if you skip the live transmissions in Kontakte or Discord, it's no big deal. You can watch these videos and still complete the exercises and still keep up with what we are doing. So thank you very much again. See you next week. Bye bye.